Hello everyone. Today we're excited to share our final report on big data and machine learning. Let's dive into the fascinating world of data by exploring the two datasets we chose. Our journey begins with two intriguing datasets. The first one analyzes Indian houses, while the second dataset is the National Health and Nutrition Examination Survey 2013 to 2014 age prediction subset, which we'll explore in a bit. Let's start with the Indian house dataset, which includes the following column. Area, BHK, which means the number of the bedrooms. Bathroom numbers, furnishing style, locality, parking lots, price, status, transaction type, building type, and price per square foot. To unravel insights hidden with this data, we begin by importing pandas for data manipulation and analysis. For visual storytelling, we use matplot library, pyplot, and seaborn. We also bring in several modules from sklearn, our trusty machine learning library. Next, we introduced a custom transformer class called correlation coefficient. This class, inheriting from base estimator and transformer mixin in sklearn, is designed to compute the correlation coefficient matrix of our data. The fit method returns self, and the transform method calculates and returns the correlation matrix using pandas core method. We then define a function named createPipeline. This function constructs a pipeline using sklearn's pipeline class, which includes scaling the data using standard scalar to ensure that each feature contributes equally to the analysis. Next, calculating the correlation matrix using our custom correlation coefficient transformer. And our function loadCSV loads the dataset into a data frame. Next, the core analysis happens in the analyze correlation function, which calls loadCSV to read data from specified CSV file, extract the specified column from the data, creates a pipeline using createPipeline, fits the pipeline to the selected data, and transforms it to get the correlation matrix. Return the correlation matrix along with the selected data. Now this code is how we plot the figure. Now let's visualize the magic of our data analysis. First, we plot a scatter plot, for instance by taking area and price as two variables. We observe a strong positive correlation, which means as the area increases, the price per square foot tends to rise as well. We also create a heat map using a function called plot correlation matrix. This function takes the correlation matrix and column names using seaborn to generate a heat map. The heat map vividly shows the strength and direction of correlation through colors, making it easy to interpret. Additionally, we analyze the proportion of furnishing types in Indian house through a pie chart. As we can see, over half of the houses are semi-furnished. About 30% are unfurnished, and only 15% are fully furnished. Let's now shift our focus to the second dataset, the National Health and Nutrition Examination Survey, 2013 to 2014 Age Prediction Subset. This dataset includes the following columns: SEQN, age group, RIDAGEVR, RIAGENDR, PAQ 605, BMX-BMI, LBX-GLU, DIQ 010, and LBX-GLT, and last, LBXIN. Now let's take a look at these columns. First column, SEQNs, which represent the sequence number, a unique identifier for each individual. Next, age group, which indicates the age range in the individual belongs to. RIDAGEVR, which means age in years at the time of examination. Next, RIAGENDR, which means gender, code as 1 for male and 2 for female. PAQ 605, which means physical activity level. BMX-BMI, which means body mass index, BMI, an indicator of body fat based on height and weight. LBX-GLU, fasting blood glucose level. DIQ 010, which represents diabetes status, indicating whether the individual has diabetes. And LBX-GLT, the total cholesterol level. And last column, LBXIN, which represents insulin level. We start by comparing fasting blood glucose levels with age. The plot reveals that older individuals are more likely to have high fasting blood glucose level. Similarly, we compare insulin level with age. We show the interesting trend as well. Finally, we represent a heat map for this dataset, offering a clear visualization of the relationships between different features. Now, let's conclude in the wrap. At the beginning, we spent a long time studying the use of pipelines and trying to process the data at hand. However, the disorganized nature of the data made analysis extremely difficult. After some discussion, we decided to switch to a more structured dataset for more effective analysis. With the new datasets, we observed the correlation coefficients between variables, which allow us to better understand the internal relationships within the data and proceed with deeper analysis. This experience highlighted the importance of data quality for us and gave us a deeper understanding of pipeline usage and Python programming. Thanks for your listening.